All right, welcome to the second class. I'm going to share the screen just to tell you now what I have done in last 1 day, because I promised you in the last class to upload the second half and I didn't do it in time. Um, but what's the second half is actually your first homework. That's the refresher course for chemistry. Okay, there are lots of chemistry materials, so don't be alarmed by that. The reason is we'll learn that at the different phase in the class. Okay, so you'll not use all of them today. Okay, what you'll do is you'll use some of them at some time in this entire quarter. But this is all that you will have about chemistry. So anytime you have a topic, just come back to these lectures and watch those. Okay, but we'll have lots of examples so that you'll know actually how to solve them. Uh, so let me first share the screen so that you see. Um, Let me first share the CCLE so that you know where stops are. Okay. Um, as you can see here, this is week one. This is my screen. You have a couple of stops here. I'm going to show you what I do. What I do is I typically takes all the materials that in my folder and I dump it there. So for instance, here I have a reading materials that chapter 1, 2 of the textbook. And I'm going to right now, I'm going to put the second one. So if I click that one, it will open up about some additional materials, which is a reference textbook. And you don't need to read everything. As long as you understand everything that is on the slide, you should be okay. No need to read. For instance, section 2.3, you don't have to read it. Um, Same thing, section 2. I don't know exactly, 66 you have to read. But I would suggest that go to the slide first and read those first. And if you do not understand it, you will find those information here. And below that YouTube video, you can ask me which page it is if you don't find it. But mostly I'm expecting you to read section 2.2 in this textbook. So this is a reference textbook. This is not a actual textbook, but this is the actual textbook. So that's chapter one, which will be the materials that we cover today and as well as next week, first class or next entire week. So this chapter one will be covered today as well as next week entire time. It's a big chapter because most of the engineering problems are mass balance. So we'll learn that. Um, all right. So this is all about. I just want to say that now everything is available on CCLE. What you don't find here is the recorded video materials, and those recorded video materials you will have accessed in on YouTube. And again, I want to show you there is a if you see what's the name here, CEE153 Fall 2020, and this is lecture 1 slides. And then you see lecture 2A slides. That means those are the slides that we'll cover today in the class. If you see B there, that's essentially the slides which we cover at the end when you are not or recorded. Those materials are also, you will see annotated slides because when I record, I also annotate that slides. So if you open that up, you will see, let me see, let me put the chat window so that I can see it. Yeah, everything will be on YouTube. So if you see, this is the entire first section slides. So this is the entire annotation of the first lecture. Uh, so anytime I wrote something, you see over here. So I'll go to browse it to all the way to the end where you didn't hear me last week on last class, but I put them on the. Okay, this is the second half of the class, which is pre-recorded, which means it is released. I didn't release tonight what I promised, but I'll release. It's already in my folders. But what you see over here is I go over these materials here. Learning objective, what you should know in that recording. Um, and this is a lot of materials. The reason is this is going to be applicable for the entire quarter. Anything related to chemistry, this is all you need to know. But again, it will be distributed across the quarter. And so I'm going to show you that you can see there are a lot of annotations, and it doesn't make sense when you read that here. because what is this arrow mark? So that's why you need to hear that YouTube, and then you see the transition, what I wrote, what I was speaking, you'll be able to relate to that one. So what
So
I'm, yes,
uh,
right.
so the YouTube video, it's gonna be uploaded later, right? Today?
Yes, yes.
Okay.
I'll upload immediately after the class because it's already recorded. It's just I uh,
Okay.
didn't upload it.
Thank you.
Um, so this entire section 2 is the homework one, which is refresher course for all your chemistry. But every questions that I have on the homework, at least I solve similar question in this example. So you will not find something which is a complete surprise. So it has some applications. As you can see, why lead is more toxic than calcium when it has 2 plus charge. I explained those here. So there are some applications. You'll hear that on YouTube. And then as you can see, there are examples. I solved it. What's the molecular weight of ethanol? So I solved that. Same thing, I have another example. What's the molecular weight of acetic acid, which is vinegar? So you see these are example already solved for you. So what you will see is the same thing when you have a homework, but it's a different chemical formula. So again, homeworks are very similar to examples. Sometimes it might be a little difficult for your creative understanding, or so that you can learn a little bit more. But at least some examples will be recorded like that. So then I go over about different types of units, how to change those. Um, yeah, these slides are you can see on the YouTube. It's not posted yet. So I just want to browse quickly here so that you know this is what is on what you should expect. And again, usually this is a very long recording. It's not traditional second half because this is just meant for a refresher course. So there are a lot of materials. But what I'm going to record the second half of today's class will be a lot less because that's basically example 3 or 4 examples. So which will be something like 45 minutes cumulative. But this what you see over here is a lot actually. And that's because it is needed for the entire quarter. Yeah, I'll post the homework today. It will be due next week by midnight. Okay, I'll write in on the homework. So again, these are all you see. There are a lot of different annotation here. I don't want to go through these things, but I just want to say that these are all being recorded. These examples are what your homeworks are like, and um, so the next class, which is now today, will be mass balance. So we'll learn about that. But at least I just want to know that you should be aware of that. These are all at least posted on CCLE. So anytime you are looking for PDF, you'll be looking in the CCLE program. And also I'm going to initiate campus where you can actually interact with your colleagues, your friends. That is much easier than emails. So I'll enroll in you on campus you'll receive an email later today. That way you can ask questions related to homework or any slides also in the campus and that way other students can answer before me if they have the answers, or TA can answer. There is a construction here, so it's always noisy. All right, so that's all. So what I'm going to do is I'm going to pause the recording so that it becomes small video every time I start a new things. All right, so you can anytime you have a questions, you could always put on the chat window so that any other students, if they know the answer, they could respond immediately. But I'll not read the notes or the chat window every minutes because that's distracting. I'll read at least every 10 minutes. And that way anything that not quest- asked or I responded, I will respond. All right, so today we are going to learn about the first and the most important engineering concept, mass balance. Mass balance, if you think of where it is applied, think of any system, environmental system. Imagine what you do at home. You create trash, and those trash you dump inside a dumpster, and those dumpster goes to landfill. Landfill, they put everything and cover it up, and that what happened to those mass? It produced methane. That methane you can use as energy. It produces leachate. That leachate may have some chemicals that you have to extract. So when you think of landfill, you have to think of how much methane you are going to produce. So it all depends on how much materials you have used, how much materials transfer from one system to another. So it's always mass transfer. So that mass transfer, the whole principle is that total amount of mass is conserved. That means it can convert into one form to another, but it's always constant. So you can use that mass balance concept to solve many engineering problems. So that's what we are going to learn today. When I say system, it could be a lake, it could be just your home, it could be river, it could be any system you think. So you will define those system and you will basically quantify amount of stuffs coming in and out. For instance, we are interested in water. How much water comes to LA from different source, and how much of those water become wastewater. So that's the mass here become water. How much mass of water. So these are applications. So any application you think in engineering, any engineering, in fact, it's always at some point is either mass balance or energy balance, and we'll learn both in this class. So today is all about mass balance. Um, all right, so there are a couple of announcements. We homework out, one will be out today. So I am solving those homework so that I know that those answers are feasible before I release. So it will be released before midnight. So due next week, and that will be midnight. Okay. So that's 11:59 p.m. Okay. The reason is it will be on CCLE. So you have to upload on CCLE and scan copy. As I said, it will be you can use your cell phone, take a pictures, but use an app. That way it looks nicer. Because if you take a different angle, sometimes it's very hard to read, or the shadow and all that stuff. If you don't know what app it will be, you can ask. I'll post on CampusWare. There are some app, but I'm not recommending any of them. You can use whichever you want, or I'm not promoting any of them. Whichever free, just use it. Don't pay for it. Um, I think again, I just want to say that this homework is all about chemistry refresher course, so that's why it is. I didn't do it. But again, there are always examples on that YouTube video. So anytime you can understand, watch that YouTube video and do it exactly same way. Um, and if you still cannot do it, come to office hour, which will be next Monday. Because release the homework is due on Wednesday. That means next Monday, second half, you can ask me any questions about this homework. And otherwise you don't have to wait that long. You can come to office hour, TA's office hour. They will release it what time. Or definitely this Friday you have also TA discussion session. You have two discussion session on Friday, so you might able to join there. If you miss the Friday discussion session, you can also come to Monday or Wednesday next week, um, before the class. So you have at least four opportunity, four discussion session, and then you will also have TA office hour. There they will also just wait for you to ask any questions. So you have 8 chances per week, and if you add, two chance for my classes, second half, you have total 10 chances to ask any questions, and then also you have campusware. So as you see, there is no reason why you can't solve any homework questions, because you have so many opportunity to ask. And again, you don't have to come to every single discussion session, because the same thing. It's just a different TA explain the same materials. So they will be also recorded. So again, just start early, start understanding. My goal is that you should be able to solve every questions, with help or without help, because we have so much resource available for you. All right, so that reading of this class today is all about chapter one. The number of page I will tell you later. I'll mention, but at least the entire chapter is kind of useful in a sense, because it talk about a lot of different things. And this is about today class, next week class too. So chapter one covers entire next week class. All right, so what's the objective today? The objective is you learn a concept of mass balance. You'll also understand the concept of steady states and unsteady states, what that means, where it is applied, why it is relevant. And also you have to use mass balance to predict the contaminant concentration in a different system. Um, so that's the today's topic. All right, let me check some chat window. Um, do you have a discussion this week? Yes, we have discussion. Oh, I'm sorry. The way I thought about it is week two is every Monday, Wednesday is the first half. Everything we cover until Wednesday will be started from the next discussion session. So that's why this will be on Friday. Though even though I said second week, if the first week of class is done, then the second week start from Thursday in my head, because you will be prepared for that. But again, you don't have to attend Friday if you don't want to, because you have Monday and Wednesday. But they will be waiting for you because we release the homework. So we want to give you as much enough time. Can you do homework on iPad rather than paper or scan? Yes, yes, you can. As long as I have a copy, where I can read it, that should be fine. Um, my discussion is on Wednesday. Was I supposed to attend? Uh, no, you can attend any discussion session. It's not you register for one session doesn't mean that you cannot attend any other session. You are free to attend any of the discussion session, any TA you want to, and go to office hour. So that's completely up to you. In fact, if you don't attend discussion session, it's up to you too. It's not mandatory. It's designed to help you. Can you have the links to the different discussion posted somewhere? Yes, I have asked the TA. So we'll have campusware so that they can post these updates, but usually they should be sending you email. So they will send you the emails but the problem is you will not receive if you have not enrolled in that discussion session. So what I'll do is I'll email that. Once they give me the link, I'll post it as a one email. But usually we'll do that campusware so that I don't have to email multiple times. It will post it there, everybody can see it. All right, so um, let's talk about mass balance. Again, as I said, why it is important. As part of environmental engineers, all the time we think of, at least me, I think of water quality or air quality. So we think of quality. But if you are a water resource engineer, you are also interested in amount of water. So think of, if you are engineer here and you want to know in next 20 years how much water LA city need, do we have that enough water? And then when they calculate back, they found that they don't have enough water. They cannot, even though they export most of their water from LA River, not LA River, from Colorado rivers and North California, that water availability is not going to change, but number of people live in LA is going to change. So you can't continue to export the same amount of water. You have to export more and more, but nature doesn't give you more. It has a constant supply. So how do you balance those out? So we figured it out that we cannot sustain it. In next 20 years, we cannot sustain buying water from different locations. So we have to reuse the some of the water. That's why we are now going for recycling some of the recycled water or the wastewater, treated wastewater, capture some of the storm water. So that's why all this design is being taking place. At the center of that decision is mass balance. And same thing, that's a quantitative aspect. And sometimes also you have to think of quality aspect. Means, imagine there is this example here, Lake Michigan, there is a toxic spill, there was an accident happens and there was a toxic substance spill from a boat. Um, or it from spill from some location from which has ammonia and cyanide, and they release into this lake, and you can see there are some dead fish here, and that's because of one of them. Maybe cyanide, but it's because of ammonium toxicity. So now question is, how do you know? Spill occurs naturally sometimes, but how do you know whether this is going to be toxic or not? So that means you have to know what concentration it will become when it is released into the lake. That's mass balance, because you have certain amount of mass in your container that you are going to spill or accidental spill. Then you have to calculate concentration. Total amount of mass of that pollutant is constant in the system. So that means you will able to calculate what the concentration would be in this lake. So that's example. That's just one example of where you can do it. Um, So anytime you see a news, something that we'll do in campus fair, I'll share a news and you have your goal is to understand it. So now first thing you have to think is, what's the reason fish died here? Okay, you have two materials, cyanide and ammonia. Well, ammonia doesn't feel like toxic because it's nitrogen. Cyanide, you hear in a James Bond movie, uh, they take a cyanide tablet and somebody died. Okay, so that doesn't happen here. That's not that toxic. So it's ammonia toxicity. But now question is why ammonium is toxic for fish when it is used as a fertilizer? Because if you think many fertilizer you use ammonium phosphate, ammonium phosphate. So ammonium, that's the formula. You have ammonium and you have phosphate. Nitrogen and phosphorus are the nutrients that the plants need. So we are applying a nutrients for the plants, and it's not toxic, but somehow it is toxic to fish. Why it is it toxic? There are a couple of things you have to understand, and that's why you need to learn the previous chemistry class or the things that we uploaded, so that you understand what the ammonium is, why it reacts, what it does. So that's the reason it is. Well, ammonium. No, just to ammonium, it makes them not breathe because it bind to that cells that helps them breathe. So it's almost like choking them. So if you have ammonium because of that plus charge. So how do you treat it? Well, you learn that in chemistry class, or you learn at some point in this class that because it's positive is toxic. So what you have to do is just make them not positive. And so ammonium, the way it make them not positive, you kick out that positive charge. So what happens is you can make NH3 and H plus. So you just have to release that protons, and so that means you add some materials that takes that proton away, and it become ammonia, and ammonia is a gas, so it will release into atmosphere. So as you see, this reaction depends what kind of decision you are going to take in that river. Depends on the chemistry. As I say here, if somebody says there is ammonia spill, oh my God, what should I do? You know that you have to release the hydrogen. So that means hydrogen is attracted towards a base. So you have to dump something which has a lot of negative charge. So you know that carbonate has negative charge, which is basically the let's say sodium bicarbonate, which is basically your baking soda. If you take baking soda and dump in your water, it becomes carbon dioxide carbonate. This carbonate will react with hydrogen because negative charge. So now that means if you add those, all the ammonium will break into ammonia gas and release into atmosphere. So that's the treatment process. So again, as I said here, the remediation depends on chemistry or biology, but the how do you know how much ammonium is there is engineering, is the mass balance. So you will that learn today. Um, Let me just say that any engineered system, as I say, is a conservation of mass or energy. So when I say a system, it could be your home. So imagine you are in winter and you say how much heat energy you need to keep maintain a temperature at certain temperature. Well, that all depends on how much heat is escaping outside, and that also depends on what's the outside temperature. If you know outside temperatures is very cold, then more heat is going to release outside. That means your heater should release, to compensate that, it should release more heat. um, for some reason I wrote something and I don't see it here. So maybe the screen is frozen. So what I'm going to do is I'm going to stop the recording and restart the screen.
No worries.
Right. So if you're interested in how much energy you need to heat up your entire home, it's all about how much energy you lose. So you lost how much energy needed to energy need to maintain at certain temperature is equal to how much and then plus energy loss should be total energy you should be supply. Okay, because you have to supply more than what you need because you know that you are losing something, and that's the energy balance. Same thing if you think of how much water you need. It's all about how much water you consume per day. So let's say, um, then let's say water supply is water use plus water storage. Okay. Um, so that's the supply you should have. So this is mass balance. The top one is energy balance. So we'll use that at different concept. So to solve these problems, you have to think of what's your system, okay, and what's the different channel that the energy or mass flow. For instance, here this is your home. You want to know how much waste you are creating. So that means you have to define your boundary. So I define my boundary based on the home. Let's say this is my system boundary, okay, and we call that control volume because that way it's allow you to distinguish what is outside versus what is inside. Okay, so we'll know how to draw that control volume shortly. And then this is become system boundary. And then you have things coming in. So this is in, there is two out. Okay, one is the things that you are recycling, goes to recycling bin, which is still going out of your home, and there are some going to solid waste that goes to landfill. Okay, so this is mass balance. Okay, so that means if you say what is the mass balance here, total mass coming in should be mass going or recycle plus the mass of the cycle as solid waste. So that means total mass is conserved. So that's mass balance. So now how to define system in environmental ways? So think of home is very easy because this is a boundary. You can feel it, but you can't feel it for a river. That means you got to find a way to make the boundary. So let's see, define a system. For instance, coffee cup. You want to know how quickly it cool down. So that means your boundary will be that cup. Okay, but there will be, it's open system because that means the mass can be lost because of evaporation. You lose some moisture. The heat can be lost to atmosphere. So it's open system. Lake is open system, but if you put a coffee cap on top of it, it's become a closed system. Okay, so closed system means you cannot transfer mass out of the system. Open system means the mass can be out. Remember that in a closed system, your energy can still transmit because energy doesn't require a mass to transmit outside. It can conduct through the mass. And that's why in a closed system, even your home, you can lose energy. Okay. So again, when you think of what is open versus closed, open versus closed, is closed for mass transfer, okay, not energy. Open system means that the mass can also flow. So river is open system. So for instance, let's say I'm interested in only this section of the river. So that you can say things are coming in this side, things are going outside this side. So this defined as a system, and I define that as a boundary. Okay. So here the boundary I can say is this because things are not spilling outside. Okay. So that way you can call it as a boundary. So now question is, there are different kind of system you deal with: lake, river, ocean, pond, pipes, all those things that you can think of, things move from in and out. Need to define boundary because that boundary will tell you what happens inside the system. And so that could be very arbitrary, sometimes it's intuitional, sometimes it's not. But you have to define that first before you solve it, because that boundary will define how much things moving across that boundary, how much mass coming in and out. So for instance, here there is a pipe. So it's convenient to say a boundary like this because that can, it takes some portion of the one pipe and the other pipe. But it can be random, like here, right? You can define something like airflow. You just take random sections. So let's have example here. So now, if you are interested in how much the gas, let's say this is a chemical plants and it's release some fume, and you want to know how much fumes are distributed across the atmosphere. Or if your home is here, you want to know how much contaminants coming to your system by storm flow. So, well, how do you define the boundary? You can do the entire thing, but then you don't need it now because your fume is only this here. So what I'll do is this is the boundary. Okay. So things are coming in from the system, that's in, and then leaving the system out, distribute. And that way, anything that's transferred from this system, you can calculate total mass of amount of stuffs released into atmosphere. Okay, so that's just here. So this, what about here, the second one, which is a lake? Well, you can draw anywhere, but you are interested in water, so why not to draw the boundary based on the water level? So I'm going to say this is the my boundary. So that means water that comes in because of rain, storm water. First is rainfall, rain is coming in. This is storm water or or runoff, and then you may losing some water to groundwater underground. So you have two incoming and one outgoing. Actually, there is I didn't write the outgoing, which is let's write. The outgoing will be evaporations. So you have three in and you have one out. So if I say what is the total amount of water in the system, so amount of water in the system, lake water or lake volume would be whatever coming in minus whatever going out. The remaining amount will be the lake water. So in is rain plus runoff, and out would be one is evaporations, another is you are losing because of infiltration into ground. So that's the ground infiltrations. Okay, so that's the remaining amount. Remain is the volume of lake. So that's the mass balance for lake. Now for the river, I just draw it. So I'm going to do it again. Just draw the line. This is coming in, it's going out, assuming that's how the water is moving. I'm just drawing the arrow. That's the flow. So that's how you can calculate how much pollutants are passing through that system. This is a stormwater system where you capture all the stormwater or the runoff and you treat them and release into storm drainage. So when you want to know what's the concentration here, what's the concentration of contaminants in the outlet, how much you're discharging, if you want to know, you have to create a boundary. So that means you can create a boundary like this. Okay, so this is out. Coming in will be stormwater and rainwater. So this is in, this is in. So I have two in. Okay. So any engineering system, when you walk outside today, if you think there is a mass being transferred, whether water or anything else, you can also visualize that. Okay. So for instance, if you want to know in a class, if I order pizza and you want to know how much smell you receive at the end, it depends on the volume of the entire room as well as how much it transmit. So you can say the boundaries outside the pizza and then you can write that equations. So I hope you all understood the control volume. You can draw for anything. So there will be one quiz questions on drawing the control volume or recognize that volume or control or the boundary. So this is just a for example I just saw.
I have a question. Can you?
Yes.
I'm sorry.
Yeah. Stop me anytime you.
Can you go back to the other picture with the lake?
Let's see. Which
Why?
one? This one. This
Oh
one.
yeah, this one. So why is there three in and one out? Shouldn't it be? Isn't it like the rain and the stormwater are going in, and then the ground and the evaporation are both out?
Oh, I'm sorry. Actually, those are two out. You see, the arrow mark is out of the system. So evaporation is out. This is in. So yes, there are two in, and this is two out.
Oh, okay. And then, so what is the three in equals one out?
Oh, I'm sorry. You are right. I made a mistake here.
Thank you.
So there are two in and two out. Thank you. Any other?
Yes, Professor. In the fourth
Yeah.
picture, the volume that you drew, it seems like it's like has like water and land and like grass,
Yeah,
but we're measuring water, right? So what does
just
that?
water. Yeah.
Okay, so what is the control volume there? Is it supposed to encompass the like the land as well? I don't know if I'm looking.
So control volume means what's the boundary of the water that you are interested in. So that the boundary I draw is that small garden or the small ditch. Okay. So it could be arbitrary, whatever you, as long as you define it, then you know what is in and out,
Okay, thank you.
right? All
On
right,
a
great. Yes.
on a quiz, when you ask for your control volume, you also want the ins and outs.
Uh, can you say again, Courtney?
On a quiz, when you ask for a control volume, you also want the ins and outs defined.
Yes, yes. Well, you'll see example in the homework, the next homework, not this homework. Okay. So you'll have again everything I ask on quiz. You'll see that as a homework as well as example in the class. Okay. So you'll have practice. Let's see any message. Not sure, but I think it's a pipe. The fourth picture. Yeah, those are pipes at the bottom. Those there'll be storm drainage. Those pipes coming out of the system. Anyway, so now question is, what is steady state versus unsteady state or non-steady state? Steady state means the amount of mass coming in and out of the system is constant. So, so here, if you think this graph, if you draw the time, so anytime you think of steady state or unsteady state, it's mostly about the time. Okay, does the mass that flow into the system is constant all the time? It doesn't change over time, then it's a steady state. If it is changed time, then that means the unsteady states. Why it is important? Because if the amount of things coming in and out, going out is constant, then you have a constant system inside your home. But if you're changing, things will start accumulating. So the amount of system or mass that accumulate in a system will change only when you have unsteady state. In a steady state, it doesn't change. So that means change is mass of a system dm by dt equal to 0. Okay, that's the mathematical way to explain the derivative. So amount of change in mass. So that means amount of, if you record your time, time start now and after some time that delta t is here, and you see did I accumulate any extra stuff within that time? That will be delta m. Okay. So delta m, so that's the derivatives. We use a simple derivative, not partial, it's a differential equation. So dm by dt equal to 0. So if you solve it, that will be dm will be 0 because dt multiply into 0. So that means if you now integrate it, so that means it's become mass of the system is constant. Okay. So steady state means the mass of the system inside the system is constant over time. That's all the definition is. So that graphically represent here. So think of, this is more like a bank balance. If you spend everything you earn, your bank balance is not going to change over time. Okay. So initially, let's say you don't have enough money, and then you earn some money, and then you start spending. So that's why you accumulate some cash, and then after a point, you start spending more. Whatever you are earning, you are spending it. So your bank balance will not going to change. All right, so mathematics of mass balance. That's how we're going to solve it. So let's start solving it. There are a couple of things you have to remember. Mass balance is not concentration balance. Mass is conserved. Concentration is not. When you think concentration, that's let's say milligram per liter. Okay, so that means how much contaminants in per liter. If you add extra amount of water, that the concentration is going to change, but the amount of contaminant is not going to change. Okay, so imagine you have a salty water. You take a glass of water, it's too salty, and you want to you say I can't drink it. So I add another glass of water, and if I ask you, did the salt amount changed? Well, salt amount didn't change. You are still going to drink all of that. So that means all the salt is going to be in your body. What you change is the taste. That's the concentrations. Okay. So just remember that it's not concentration balance, it's mass balance. So how concentration is related to mass? Mass per volume is concentrations. So anytime you have to change to mass, you have to multiply concentration times volume. Okay, that's the one thing to remember. Again, mass balance is this accumulation rate, which is dm over dt in a system, is a mass input rate, amount of mass you're adding into the system. So dm by dt that's coming in minus amount of mass leaving the system per time, dm out by dt, plus or minus mass transfer within the system or the reaction. So what we call is dm by dt reacted. And the now question is why plus minus? Why not just plus? Well, the reaction can actually create mass, or reaction could create means whatever the things you are trying to capture. For instance, let's say you are talking about water balance. What if you are generating water by condensing all the moisture in the atmosphere? Then you are actually creating mass from some other form. So that's why when you are creating mass, it is positive. So positive means the reaction create mass, the specific mass that you are trying to calculate in the system. Okay, and negative means reaction not create it destroy specific mass or contaminants. Okay, so if you think of wastewater treatment plant, we destroy stuff, we destroy the contaminants, so that's why it's negative there. So let's solve that questions. Mathematical mass balance. Derive the equation mass balance for water in a lake or pond with the flow in and out. Okay, so I'm going to do that for a lake. The thing that we do pond, let's do that one. Positive, negative, yes. Positive or negative, yes. Let's see. Yeah, this is positive. Sorry, a lot of times I assume a lot of things, I remind me. Okay, this is a lake, and we know that there is a rainfall that's coming in. So I can write Q rain. That's the amount of water that comes in. Q is the flow. Okay, Q is the flow. That's the notation, flow rate. So that's dV by dt. Okay, volume of amount of volume that transmit per time. That's the formula. So now what's leaving the system? What's coming in as a runoff? So think of this is like a flow, Q runoff. That's coming in. What leaving the system is evaporations. So and then infiltrations. That's into the ground. Okay. So now if I say the mass balance, so this is lake. What do you want to do? Just write it there. So again, you see, I talk about mass, but I'm writing Q. There is a discrepancy because I said never use volume, but I'll get to that point. So let's write this one. Q in equal to Q out. That means all the mass coming in is equal to. So then we can write Q in. All the Q in, it will be Q rain plus Q runoff. It will be Q out, will be Q evaporations plus Q infiltrations. Okay, let's say why this is a mass balance. Where is the mass here? This is we are talking about volume. Well, there is a reason why we interchange volume to mass. The reason is, if you think of what is mass, mass is a let's say mass equal volume time density. Volume. I'm going to write it in a way that is clear. Volume times density. So volume is V, density is rho. That's the notation I use. Okay, so volume time density. Density is constant. So if you write dV by dt, volume equal to d by dt, volume we can replace by mass over density. Okay, and then it become dm by dt, 1 over density. Or another way to say is dm by dt is density times dv by dt. And density of water is a constant. So all these things over here, if you write this one, and this is density times q. Okay, so if I write this one, it will be actually q equal to be d, this will be or q equal to 1 over density times dm over dt. So if I write this one, it becomes like 1 over density and dm rain by dt, dm runoff by dt. Same thing here, 1 over density, because it's common everywhere, dm evaporations by dt, dm infiltration by dt. Density cancel out. So this is your mass balance equation. It looked like a mass of things coming in called mass. So the reason it's important is because density of water doesn't change in a system because you are not compressing them. It's incompressible fluid. That's why you can write that mass. You can interpret mass of water as volume of water because they are almost constant as long as the density constant. Now question is where you cannot use. Think of where the density will change. Well, density change if you have very high pressure system, if you compress them, but it's incompressible, still you can avoid that. But what if you add high temperature? You boil the water, then the volume of water is going to change because of high temperatures. So that time the density is become lighter. Or another thing is if you're mixing salty water with a fresh water, salty water has a different density. So then you have to take into account mass, not the volume. You have to account for actual mass derivations. Okay. So I'm going to write this way: dm by dt. Always start with that equal to dm by dt. This is always consistent. Then you place m equal to density times volume, then you get the flow rate. Okay, so you'll start always with dm by dt. So the formula is here for any water because as the environmental engineer, we deal with water. You can always assume flow rate. You don't have to start with mass.
Professor
So
Mahanti,
yes,
does this assume a steady state? Like why isn't the control volume represented here?
yes. So this is steady states. I didn't say that this whole thing that we did is a steady state. That means
Okay, thank you.
there is no accumulation. That's why we can say in what's coming in is equal to coming out. What if you're losing some other word? Okay. But that's a good point. Let's talk about unsteady state. Okay. That's where your system has some changes, which is here. Okay. So for instance, let me do one thing. Let me add a new page and we discuss about unsteady state. Okay. So let's say there is unsteady state, so that means what will happen is change in mass of lake water will be that's all the things that's coming in minus all the, this is summation side. Okay, sum total sign. Okay, dm by d out, that's going out. Okay, we already discussed that this will be q ren, density cancel out, so that's why I say no. Let's put the density. So if I remember what um, m is, dm by dt equal to density times flow rate. So density times flow rate. Okay, so that's sum. Let's not write sum because we already know what the different are. So density of water times then plus density of water times the flow rate of what's coming in is runoff. Okay. Then if I take the density common out, so you can write everything like this, minus q infiltration that we are losing, and also minus q evaporations. Okay, that's the right side. Whatever the left side is a volume. So mass equal to density times volume. So d by dt, density of water times volume of lake. Okay. And then density is constant, so it can come out of the derivative. So it will be density times d over dt of volume. Volume of lake, how the volume change over time is the density times all that. So density cancel out. So it will be Qn minus Q plus Q runoff plus minus Q infiltrations minus Q evaporations. Okay, so that means density cancel out. So your non-steady state equation is this. What it means is change in lake volume would be the flow that comes as a n minus flow comes as a runoff. Sorry, plus then minus Q flow rate that leave the system as infiltrations minus Q as evaporations. Okay, so that's your non-steady state formula. So that means if you want to know what's the volume of lake at any time, all you have to do is integrate it. So dV, if you integrate volume of lake, would be all this term. Okay, so I'm just going to say Q's, all the Q's here. Entire thing is Q's times dt. Okay, and so at time t equal to 0, you have certain amount of volume. Okay, so that's the initial volume. Let's say V initial. Okay, and then after some time t, you want to know what's the volume of lake, so V final. So if you the flow rates, as long as the flow rates are constant, that's constantly raining, constantly doing all that stuff, then you can integrate that. So that means it will be out of the equation. So it will be V final minus V initial would be Qs, because it's a constant. You are saying that the flow rate doesn't change over time, and time t minus 0. So that means V final is V, whatever the initial volume of lake times change in flow rate now, some QH now. So that things times time. Okay. So it makes sense. Now, if you think what that means, you are saying the amount of flow, the amount of volume in change, the final volume is whatever initial volume plus the flow rate, net flow rate that coming into the system times the time. So that's basically the formula. So with this, so QS is Q rain plus Q runoff minus Q infiltration minus Q evaporations. Okay. All right. So that's what you can solve the unsteady state. Any question? Otherwise, it's a very good question. So that there is a question related to that. All right. So the final last part of this class is you will learn how to solve the volume, which is mass. But most of the time, we are not interested in water. Because water is not toxic. What is toxic is contaminants. So you want to know that spill example. What's the concentration? What's the change in concentration in the lake after that ammonia spill? So let's start with the mass balance equations. So this is the formula, but I'm going to derive that one. I'm going to show you how it is. You do not have to derive in the exams unless that system is not given. You can directly use this equations and then start solving. Okay. So let's say in a lake system, things are coming in, things are going out. I just wrote one out, but it could be multiple out. So just we know that we can sum it up. And we have a volume term here. That's the volume of lake. And in the incoming, so this is Q in, Q out. And then also you have some contaminants coming in the spill. So this is C in. This is the amount of pollutant that's coming in. This is the amount of pollutant that leaving the system, that's concentration out. And then you have also the amount of pollutant in the systems. Okay, so these are the different concentration terms, 2 flow terms, 1 volume. So now let's write the mass balance equation. All right, so let's start with the basic. What we start? Change in mass. Change in mass in a system would be total mass coming in minus total mass going out. Okay, and then, as I said, plus or minus reactions. Okay, so I would say that, let's say the reaction, I will just put it here. The reaction actually destroy the reactants, because I say ammonia gas can leave the system. So let's say the reaction is actually, so Q is somebody asked what is this? This is flow rate. C is concentrations. Okay, just so that you know the notation. All right, so the reaction is the amount of mass reacted, or reactions. And here I put minus sign. The reason I put minus sign is because I'm assuming the reaction actually destroy that contaminants. So negative means, or negative sign means it's a destruction of the reaction destroy the contaminant of interest. Okay. So let's solve this one. You can change it to a plus if it is creating inside the system. All right, so let's write this one. So I'm going to solve it. Let's see if I have a space in the other slide. Okay, it's a deriving. So I'm going to derive that one here. All right, so let's see. What's the M system? M system, mass is equal to volume time concentrations. This is not water. This is a contaminant. So dm by dt will be d by dt, volume of system, concentration inside the systems. And if you assume that volume doesn't change in the system, which is the case in a lake or river, because the spill amount of volume is not enough compared to change the volume of water. So the amount of spill is usually very small volume compared to the entire lake volume. So here again, we are talking about the contaminant mass. It's not talking about the water system. This is about contaminant, not water. So that's why I say mass of the system means mass of the. I should write contaminant here just to be more clear. Mass of contaminant in the system. That way you don't have any confusion with the volume of water. Mass of contaminant in system. Okay. CONT is contaminants. Okay. That's one here. All right. So volume of system doesn't change, so you can derive it out of the system. So this become dC by dt. Okay. Volume of system. That's this side. Now let's do this one.
Professor, so
Yes.
C is the contaminant, right?
Yes, C is contaminant concentration in the lake.
Okay.
As you see over here, this is lake. You know that the dm by dt, we derived that before. Let's write it now. Let's write it here. I'm going to solve for the second one, dm by dt in. Okay, how much contaminant coming in? Again, same thing, d by dt. You have a mass equal to volume times concentrations, right? So now this volume is the flow, things that's coming in, not the lake, because this is a system that is flowing into the system. And here the volume can change because the flow rate can change, but the contaminant that in that flow, because toxic things in the system usually doesn't change, because we are spilling something which has a constant amount, or concentration is fixed in that whatever the liquid you are carrying. So the concentration come out of the system. So you say dV by dt, and this the amount of volume flowing into the system per time. So that's equal to C times Q in. Okay. So in the same way, you could write dm by dt out would be C in here, C out times Q out. Okay, so that's why you see these two terms become C in and C out. Okay, and if you have multiple, it does add summation, some value if you have multiple stream coming in and out. The final one is a reaction. Reaction term is dm by dt reacted. Again, reaction doesn't happen inside the system. So again, this will be d by dt, volume times concentrations. And here, the volume of the system doesn't change because we are talking about reaction. Reaction doesn't happen during flow. It happens inside the lake. So here the volume is the amount of water and site where the reaction happens. So that will be volume of lake times dc over dt. Okay. So this is, I'm just going to write reactions just so that we know. So that's why you see this entire term, if you put all this value, this entire formula is become like this. Okay, so let me write the final formula. So the final formula based on the reaction, first order, second order reactions, which will just dc by dt. If a first order reaction, that means that change on concentration depend on the concentration itself. So it's proportional to concentration of that substance. So what you are saying in the first order reaction, amount of contaminants concentration change is proportional to whatever contaminant available at that time. So that means dc by dt is equal to some rate constant. This is kinetics in some chemical reaction formula you learn in the. So just remember, first order means dc by dt equal to kc. K is the reaction constant, rate constant. This is rate.
Quick question.
Yes.
In this proportionality that you wrote at the top
Yeah.
right here, are the two C's the same thing?
Yes.
Or
Same thing.
okay.
So dc is change in concentration in the system is proportional to the same concentration. Is think of how much reaction happens, how much noise happen in a class is based on how many people are available there, right? So it's the kind of same way. So KC. So if you put that all this thing here for the figure I draw here, so your system mass balance will be, I'm going to start putting here B of lake dc by dt. C is the system inside. Okay. Then Q in, C in, because there is only one Q in, one coming in, Q out, C out. Then reaction, I said it's destroying, so it's a negative sign. Then volume of the lake, C in the lake. Okay, so that's your mass balance equations. Okay, so you can assume that, and this is what you are going to solve for the concentration term. But there is one assumption here. Think of what is out here. The contaminant that coming out of the system is almost same as the contaminant in the system because the reaction doesn't happen once you leave the system. So usually you can assume what is C is same as C out. Okay, the reason is it's like your bucket of water. The reaction happens inside the bucket of water and then you pour it. So what you pour is what is in the bucket. So that's why the concentration doesn't change outside the system. That's assumption that reaction doesn't happen outside the lake. So if you put that one, what you are going to do is you're going to erase that. You say C out equal to C. So that means all these things you can take that out. So now you have a two C terms. C in is known, Q out, all those things are known. You just have to solve for this. So this is a linear differential equations. You will solve it. We'll learn that one. That's the calculus part. That's the only calculus or math you need to know. But you don't have to solve it. The solution of a linear equation is known. You can have that formula and you can always put it as a solutions. But that's all. That's all the math or calculus you need to know. All
I
right.
have one
So
question.
yes.
Sorry.
Go ahead.
So you went from V Lake DC reactant DT to just V Lake C. So why isn't it V Lake KC?
Oh, can you say again? I didn't really see.
I'm confused because you said DC DT is equal to KC, a rate constant. And then
Yes.
you went from V Lake DC
Oh yeah,
DT
you're
to
right.
just
You're right. I'm sorry. There is a K term here.
Thank you.
reaction. Okay. Yeah, I'm sorry. That's good. Good. All right. So that's the K term here. So now how to solve it? That's the calculus questions. Okay. But point is you can solve if it is a steady state reactions, then you know that dc over dt equal to 0. That means you can calculate C just if you know the C in. Okay. So if it's a steady state, this C, there is no change in time, nothing change in time. So any derivative of time will be 0. So that means you can calculate if you solve for other one. So C equal to Q in, C in divided by, so I just rearrange everything what is there in the top equations. Q out plus K reactions times V leg. Okay. So that's the solution for concentration in the lake if it is steady state reactions. That means your things are coming out. And the K is rate constant. That was the unit of rate constant. If you say what is the rate constant, think of a dimensionless analysis. Concentration, let's say milligram per liter, that's my unit. So if you say unit of constant, rate constant, you can just use that equations. So K times concentration unit is, let's say, milligram per liter. That's for, I'm just saying that, that's some assumption. Here, milligram per liter, that's the numerator, and denominator is time. Let's say we talk about hour or days. So let's say day. Milligram per liter cancel out, so the K will be 1 over day. So rate constant of a first order reaction is 1 over time. Okay, so it's 1 over time, whatever the time unit. So you can see dimensional analysis. Concentration term is Q. So this is a Q times C is going to be mass. This is Q, which is mass, or this is mass times volume, and then K is 1 over time. So it's all balanced out. Okay, so this is volume over time is flow rate. So if you do dimensional analysis here, it will all unit will be cancelled out. It will be as concentrations. All right, so I'm not going to solve any beyond this one because we'll do that again and again for examples. So that's all about the mass balance concept today. This is already 118. So if you, what I'll say is this is the end of class now. So we can wait for second half where I'll solve this one. So if you have to leave, you can leave it. So I'm going to stop share right now. I'll stop recording.